Hi, my name is Brendan Darrer. During the past few years, I have been working with a research team called the Model G and Vortical Motion Group that currently has 7 active members volunteering their time to computer simulate a novel reaction diffusion system, one that could bring about a quantum jump to our understanding of the physical world. Our group is sponsored by the StarBurst Foundation, a non-profit scientific research institute conducting leading-edge transdisciplinary research in the fields of physics, astronomy, geology, paleontology, and systems theory. StarBurst is supported entirely by charitable donations. Information about it can be found at starburstfound.org. For over 35 years, StarBurst has been working on a novel approach to physics called subquantum kinetics, developed by physicist and systems theorist Dr. Paul Laviolette. Subquantum kinetics represents physical phenomena in a unified way by modelling a specific set of reaction and diffusion processes proposed to take place at the subquantum level. These are described by a set of 3 partial differential equations called Model G. Subquantum kinetics may be the long-sought theory of everything. To date, over 13 of its predictions have been subsequently confirmed by observation. By comparison, Einstein's general theory of relativity had only 3 confirmations. Subquantum kinetics not only describes phenomena currently known to academic physics, but also opens up new horizons to understanding out-of-the-box phenomena that previously had no proper explanation. Currently, our research team is carrying out computer simulations on Model G. This simulation effort is critically dependent on computer processing power. For this reason, we are seeking contributions to acquire time on cloud computing platforms such as Google Cloud. Past computer simulations of Model G, performed in one dimension, have shown that its equation system is able to spawn particle-like soliton structures that closely represent neutrons. The following video, for example, shows how Model G is able to spawn a neutron-like structure from an initial zero-point energy fluctuation. This early simulation work involved use of a C++ code using exponential time differencing to solve the PDEs of Model G. It is described in the following journal paper by Matt Pulver and Paul Laviolette called Stationary Dissipative Solitons of Model G. The soliton that finally emerges in this simulation is found to have an electric field contour similar to that observed in the core of the neutron. Compare profile Y shown here to the charge distribution found in the core of the neutron as seen in the following image. This second image is taken from a paper by Dr. James Kelly 2002 of Jefferson Laboratory, who probed the neutron structure using high-energy nucleon particle scattering data. The field profile predicted by subquantum kinetics made a closer match to the neutron's observed field contour than any existing theory. In addition, the subatomic particle soliton that Model G is able to create has been shown to accelerate in the presence of a simulated gravity field gradient, as would be expected for a real material particle. We believe that further simulation work of this amazing model will reveal far more in the way of physically realistic behaviour. Over the past year, the Model G and Vortical Motion group has been attempting to progress this work by including vortical motion or rotation into the reaction diffusion equations in the hope of modelling quantum particle spin. Currently, we are also working to simulate Model G in 2 and 3 dimensions. We hope that this will eventually allow us to simulate solitons that demonstrate the ability to elastically scatter from other solitons in a way similar to what takes place in the physical world. The Stack Exchange page accessible at the following link summarises some of what we have been doing. Currently, we need additional help on this, such as buying enough computer processing time on a cloud platform to carry out the large memory simulations that are required for our project. We would like to ask you for your support in crowdfunding this project. Model G was first developed by Dr. Paul Laviolette in 1985 to 2012 as the most promising model for the SQK approach. He developed it by modifying the Brusselator reaction system that had previously been developed by mathematicians at the Brussels School under the direction of Nobel laureate Eli Prigogine. Model G is an open reaction diffusion system that utilizes three variables x, y and g rather than the two x and y that comprise the Brusselator. The advantages of Model G in accounting for physical phenomena ranging from the microphysical to the astronomical and cosmological levels are presented in the ebook Subquantum Kinetics by Paul Laviolette, PhD, which may be purchased at this location. These links are also given on our crowdfunding page. Book reviews may be found here at this address. Papers on subquantum kinetics are also available for free download at the StarBurst Foundation website shown here. In addition, you may be interested to try your hand at the Model G simulator available at the StarBurst Foundation website at this address. Thank you for your time.